Hello everyone, this is the Theoretical Tools of Public Finance, Chapter 2. We are going to start a very exciting chapter. In this chapter, we are going to learn about the tools to understand public finance topics. So this chapter will be mainly focusing on graphical and mathematical tools. And today we are actually focusing on utility maximization. So this part specifically focuses on utility maximization, and in chapter 3 we are going to start working on empirical tools of public finance. Okay, so this is part 1 where we will learn about preferences. We're going to learn about the term utility, and we will start talking about indifference curves and the concept of marginal utility. Let's get started. All right, so constrained utility maximization, what does it mean? This is something we use in economics to make decisions, okay? So let's say I woke up this morning, right? I went out and I'm about to buy either 1 cup of coffee or 1, let's say, cake pop from Starbucks, right? So I make constrained utility maximization. I have, let's say, $5 to spend, and I can't buy both of them. Right, my coffee and cake pop, unfortunately, they're so expensive. Both of them are more than $5. So I do constrained utility maximization. I have a budget of $5. And then what I do is, okay, what do I need the most? Some mornings it's cake pop, some mornings it's coffee for some people. But for me, with my utility, my indifference curves, I prefer coffee all the time. So let's get started. Let's see how all this works. So what is utility anyways? Utility, when you say utility in like civilian life, right? If I'm not thinking like an economist, utility, I think about, right, the utility bills, which is like electricity, water, right? That comes to my mind. However, as an economist, when I hear the word utility, that's a happiness, satisfaction I receive when I consume a good or service. Okay, that's it. So utility, before I go on, utility is highly subjective, right? I can drink a cup of coffee and I can rate it 7 out of 10. Somebody else can rate it 5 out of 10, assuming that we all judge the same quality, but it's just basically what you need at the moment. If you've been drinking coffee, you're not going to rate it really highly, okay? So that's, utility is subjective. It is not globally comparable. For instance, if I rate something 10, maybe that's to somebody that feeling is 3, okay? So let's talk about constraint. U is for utility, constrained utility maximization. So this is exactly what I was talking about. I have $5, right? I have a budget limit. That's what constrains my happiness choice, right? I have $5 to make myself as happy as possible. That's the constrained utility maximization comes. I'm trying to make myself as happy as possible. So definition says all decisions are made to maximize your well-being, utility of the individual, subject to available resources, which I had $5. That's a budget constraint. Okay, so utility maximization involves, we need to know people's preferences. We are going to see indifference curves will play into that. And you need a budget constraint, right? $5 is my budget constraint. We have monthly budget constraints. We have to pay for lodging, your house, your rental apartment, your car payment, so on and so forth. Okay, so key assumption in preferences is what we call in economics non-satiation, which means in terms of consumption, more is preferred to less. Okay, first of all, I will prefer more coffee to less coffee always. So it's the same idea. Non-satiation means more is preferred to less. This can be shown in this indifference curve setting. So we're going to take a look at preferences over different goods. So this person is not necessarily choosing between, but consuming cakes. This is the quantity of cakes. You can put it on the y-axis. This is the y-axis. And also consuming movies. Okay, this is the quantity of movies consumed. So it's a Saturday. I want to eat some cakes, cupcakes, and I want to go to movies. I have certain money. We're not going to talk about money parts budget constraint part yet. We're going to talk about preferences of the individual. Okay, so let's take a look at different bundles of goods here. Different bundles of goods. So at point A, for instance, you are consuming. I'm going to just erase this. It's going to bother me. Okay, so at point A, you're consuming 2 cupcakes, right? And 1 movie. So you went to the movies, right? Bundle A gives you 2 cupcakes and you're at the movie watching a movie, right? Another bundle, if you consider another bundle, bundle B. Bundle B gives you, you watch 2 movies and you are eating 1 cake, okay? Cupcake, not the whole cake. That would be too much. So bundle B gives you 1 cake and 2 movies. Let's consider another bundle, more of, more something that, a bundle that contains more movies compared to the bundle A, and it contains more cakes compared to the bundle B. Okay, bundle C is, it gives you 2 cakes and 2 movies, okay? So these are different points, all right? These are going to be, we're going to talk about it soon. They're going to be points on your indifference curves, okay? So bundle C gives higher utility than either point A or B because bundle C has more, 2 of each, right? So bundle A, for instance, has 2 cakes and 1 movie. Bundle B has 2 movies and 1 cake. All right. So this is, obviously, we just showed the preferences over movies and cakes. Because of non-satiation, bundles A and B are both inferior to bundle C. So bundle C will be preferred, okay? So let's talk about utility functions. So we are now moving from this, non-satiation. We are going to put these in indifference curves framework. So let's talk about utility function. Utility function, any function, I want you to know, any function is like a machine. This is something my 7th grade teacher told me. I'm going to draw like a machine, right? Like a black box. Okay, so let's put a funnel on top. Okay, there's like funnel. You put something here. You put X here. A function is like a machine. This is a function. You put X in here. It does something to it. And it spits out Y, which is f of X. Okay? So utility function is like a machine. You plug in, cookies and movies. Sorry, cakes and movies. And it's going to actually spit out some value. So that's going to be your level of your utility. I hope you will never forget this analogy. A function, any function, is like a machine. I will never forget that example. 7th grade made a huge difference. All right, so utility function is a mathematical representation. Utility, this is going to be a number, right? It just transforms these inputs, whatever these are, consumption, goods or services that you consume, it transfers into a mathematical number representation. So X1, X2, and X3 are goods consumed by the individual. It could be services too. For instance, I'm very happy when I get a nice haircut, right? So if I go to doctor, I'm actually really happy because I got healthcare, hopefully. All right, so if we put a dot, we don't know what's in it, right? We know here f of X1, X2, X3, but it's some mathematical function like that machine. So an example, utility function over number of movies and cakes consumed. What does it look like? So an example is actually this utility function is equal to QM times QC. So you're just multiplying the quantities. So QM is number of movies, right? And QC is quantity of cake. So if you go to the previous one, right? Number of movies, X. So you have f of utility function X and Y, right? Function of 2 things. You put here. When I say Y, this is the Y axis. It could be X1, X2 for pedagogical purposes. X1 and X2. This variable is considered X2, right? But it's on the Y-axis. I just wanted to differentiate between those two. All right, so QM and QC multiplication. So QM is quantity of movies, quantity of cake. In bundle A, we had 1 movie and 2 cakes, right? And bundle B, we had 2 movies and 1 cake, right? So if you multiply these, right, this is what you do. Q utility function, QM, QC. If you look at bundle A, you're going to get utility at point A, right? QM is 1 times 2. That's going to give you 2 units. If you look at bundle B, UB, that's the utility at point B. 2 times 1, again 2. So these 2 bundles give you exactly the 2 units of utility, 2 utils. I hate saying utils, but that's fine. So the combination C, bundle C gives you at point C. This is utility at point C, right? 2 of each, right? 2 movies and 2 cakes. Okay, that's 4 units. So that's 4 utils. So 4 is greater than either of these bundles. Bundle C gives you higher utility than bundle A or B. Therefore, it's highly preferred to A or B. So we say this individual is indifferent between A or B. Indifferent means either A or B are okay. Sometimes we say that, right? Oh, I don't mind. Either is fine, right? So do you want to see the Creed movie or do you want to see the John Wick, the latest one? They say it's really good. So which one, right? Oh, I'm indifferent. Means I get the same utility from either movie, which I don't. I prefer John Wick. Okay, going back. So figure 2 illustrates this. So how can we put this in a graphical form? This is what it's going to look like. So both A and B give you, both bundles give you 2 units. And they must then lie on the same indifference curve. Indifference curve shows you the points that give you equal utility. So if you go to some other point on this indifference curve here, that's again same utility as A or B. If you look at point C, it's going to lie on a higher indifference curve. So bundle C gives higher utility than either A or B. So it's going to lie on a higher indifference curve. Higher is the better. Okay? You want to move towards this direction. As you move towards this direction, it's positive increase in your indifference, in your utility. Okay, dear, I'm going to teach you something really cool, folks. You're going to love this. Okay? So here's a little trick. This is going to help you in labor economics because these are good goods. Okay, so this is, let's say, this is again movies and this is the cookies, right? So both of them, this is 0. As you consume more, your utility goes up. So put an arrow towards which direction your utility goes up. Again, for the movies, put an arrow starting from towards which direction your utility goes up. Same here, positive, positive. This is how we figure out the shape of the indifference curve. So indifference curve will be convex, which means, so let me teach you convex on concave. This is one of my favorite parts. So convex is like a cereal bowl facing up, literally. Concave is like upside down tunnel. I mean, tunnels are upside down anyways, like that. So this is like a car tunnel. I'm going to draw a car here. Bear with me. It looks like, oh my gosh, it looks like a little turtle. But you get it. This is convex. Convex. This is concave. So once you figure out these directions, you're going to draw an indifference curve that is convex to this origin, right? Like this. Okay, then I'm going to draw indifference curves like this. Okay, and the higher they are the better your utility goes up in this direction. Let me teach you something else. What if one of them is a bad good? Okay, so you're gonna laugh. But in labor economics, we study compensating wage differentials, and this is like a job risk. Literally, this is the probability of getting injured at a job. Okay, so this is job risk. It's probability from 0 to 1. It, that's how we measure. And here, put, for instance, cakes. Okay, I'm gonna put something positive. How can I figure out the shape of the indifference curves? Like this. As you move up, utility goes up in terms of cakes, right? I can actually move it here. Let me draw it like this. It's better if I drew it here. Okay, so cakes, as I consume more cakes, I am happier, positive, this direction. For job risk, I actually want to go towards 0. The higher the job risk, the lower my utility. This is like the probability of injury, okay? So I want to reduce my job risk, so my utility goes up as I move away from this maximum, whatever unit is that, but as I run towards the, because it's a negative thing, right? This is a negative thing. This is a positive thing. I will want more cakes. I want less job risk. Okay, this is a better way of showing this. Okay, so I am going to move this way. So your indifference curves are, again, look, convex to this origin. You have to make a new origin, and they will move up as you move here. So let's say this is the maximum, right? Maximum risk. So you're going to draw your indifference curves like this. If both are negative, I'll show you. That means like choosing between two bad things. But your indifference curves increase as you consume more cakes and as your job risk goes down. All right, we're done. All right, so let's finish this up. All right, so there are two. Okay, indifference curve definition. I'm sorry, I got too excited. Indifference curve is a graphical representation of all bundles of goods that make an individual equally well off. So on an indifference curve, your happiness is constant because these bundles have equal utility, okay? An individual is indifferent as to which bundle he or she consumes, all right? So indifference curves have two essential properties. We talked about this before. So these are coming from non-satiation principle. More is better assumption. Consumer prefer higher indifference curves, and indifference curves are always downward sloping. And we're going to answer why indifference curves are always downward sloping. But we need to talk about marginal utility. So marginal utility is increasing the utility from consuming an additional unit of a good. So this morning when I had my first coffee, it was the best feeling. Okay, so right now I've been talking for a while and I'm very thirsty. I'm going to have some water. Excuse me for the sounds, but if I were to rate this, satisfaction from drinking this first sip from 1 to 10, it was a 10. So I'm taking one more sip. Excuse me. It's more like 8 now. It's gone down. So if I keep sipping, after the 20th sip, this is a 40-ounce bottle. So after the 20th sip, I'm probably not going to be as happy as the first couple of units. That's going to be diminishing marginal utility. We're going to get there. So, which we are. Diminishing marginal utility means each additional unit makes the individual less happy than the previous unit. Overall, your happiness is going up. The more water I drink, I'm happier and happier and happier. But the subsequent units are valued less. This happens with, for instance, ice cream. I start eating 1 spoon. Excellent, right? I rated 10. Second spoon, still 10. Okay, 9. I've been eating, my tongue is numb, so I don't even taste it anymore. So then your marginal utility, additional utility you gain starts diminishing. Diminishing marginal utility means each additional unit makes the individual less happy than the previous unit. Okay? So in the next part, we are going to talk about marginal rate of substitution, and we are going to learn about the slope of the indifference curve. Couple of things. If you haven't subscribed to this channel, subscribe. If you haven't hit the like button for this video, do it, because when you do that, the YouTube will push it to other students who are struggling with their classes or who want to earn an A in their classes, and you're going to be helping them. See you on the next part. Bye.